Alright, hi everyone. This is a video on graphing something called multivariable equations, and we've been working on this in class. We've been doing lots of solving for x problems, or solving equation problems, and when you get like a problem like, I'm going to make something up here, 2x plus 1 equals 4. Or I could even say 2x plus 1 equals 4x minus 7, or something like that. This is what we call in math what we would name a single variable equation. So this whole thing here, this is a single variable. There's only x's in the problem. So when I'm looking at it, even though I see the 2x and the 4x, they're all x's. There's no y's, there's no a, b, c, no other variable. So that's why we call it a single variable equation. And we could solve for x. We could put a line down the middle and solve for x and get an answer. And it'd be no issue at all. But what I'm talking about when I say multivariable equations up here, what I'm really talking about is like, what if I had spiced this problem up a little bit and said I have 2x plus 1, but I had said I had equal to 4y minus 7. Well, now it's a multivariable equation. Now I have x's and y's in the problem, which means now when I look at it, I go, oh, okay, it's going to have a weird answer. It's a multivariable equation. And when you go to solve these ones, you need directions. You need someone to tell you what you're solving for. Are you solving for x or are you solving for y? And so someone's got to kind of tell you that, give you some directions. And so these are what we're focusing on today, and we're actually going to be graphing them, which makes it even that much more fun. So first, let's practice a little bit. So our first example, I'm going to have you guys all write this down, solve for w. So if you need to, if I'm going fast, pause the video so you can write all this. I want to make sure everybody's getting this written down. But we're going to do a multivariable problem here, a solve for w problem. And I'm going to give you an equation. So let's do this. Let's solve for w. And how about this equation? 5 minus 3, parenthesis w plus 2x equals 3x plus 6. So 5 minus 3, parenthesis w plus 2x equals 3x plus 6. So hopefully you're writing that down. What we're going to do is we're going to solve it. So we're going to line down the middle here. We're going to notice that the directions up here said solve for w. So I'm paying really close attention to that. If it says solve for w, then at the very bottom when I'm all done, my answer should say w equals something. So our job is to get w all by itself. Well, right now w is kind of buried in this problem. It's in the parenthesis. So why don't we tackle the parenthesis first? Why don't we take the negative 3 and multiply it in, use the distributive property, and do negative 3 times w and negative 3 times 2. So we're going to have a negative 3w plus negative 3 times 2 is negative 6x. And that 5, this 5 right here that was out in front, it's still there, so I still have this 5 kind of sitting out in front. So I get a 5 minus 3w plus a negative 6. And I didn't do anything over on the other side, so equals 3x plus 6. And I'm kind of ready for my next step. Why don't we start flipping some things around? Why don't we take the negative 6x's, move it over to this side, and make it a positive 6x, so that this thing moves over. So I'm left with a 5 minus 3w equals 3x plus 6x is 9x's. So 9x plus 6 from the end there. Man, we're getting closer, so I'm going to keep going through my steps here. Now I'm thinking, how about we take the 5 and flip the 5 over and make it a negative 5 on this side, so that we have 6 minus 5. And we'll clean this up a little bit since the 5 is gone, and we'll say we have a negative 3w equals a 9x plus 6 minus 5, so plus 1. Alright, getting closer. So now, next step, why don't we divide by negative 3? And we'll divide the other side by negative 3. We're going to break it up into the whole thing being divided by negative 3, so little fractions here. So negative 3 divided by this, and this divided by negative 3. Divide everything by negative 3. Which means these are going to cancel, and we get w equals, just like we wanted to, w equals, And we have 9x divided by negative 3x here. Well, 9 divided by negative 3 is negative 3x. Plus 1 divided by negative 3, well, that's a fraction. That's going to be like a 0.333 repeated in our calculator, so I don't really want a decimal repeated. So I'm going to write plus 1 over 3, a negative 1/3 fraction. So we get negative 3x plus negative 1/3. And if you really want to rewrite this, the plus negative 1/3, I'm going to erase this here. Why don't we just say minus 1/3 and call that our answer. So we've done some of these in class. I hope you're kind of getting the hang of it. We're going to step it up today to some more useful techniques here. So now when I'm solving these multivariable equations, I'm going to add a new direction to it. So let's do a new example here. This example is going to be graph the equation. So graph 2x minus 4y equals 8. That's my direction. So now I'm thinking to myself, okay, well, if I want to do some graphing, it's really, really nice to have everything in this y equals mx plus b form. Because if you know that m is the growth number and b is the start number, graphing is really fast. But right now, this thing is not in y equals mx plus b. It's in a totally other form, a multivariable form. It's kind of messed up. So here's kind of my thought. Because it looks a little bit messed up, why don't we put a line down the middle? And why don't we rearrange it so that at the very bottom we get a y equals mx plus b? Let's put it in a format that helps us. So that's what I'm going to do. I'm going to go after this problem a little bit here, and I'm going to rearrange it into y equals mx plus b. So let's start by flipping the 2x to the other side. It'll flip over and become a negative 2x on this side. Right now it's a positive 2x, so we're going to flip it to a negative. So moving that over leaves us with this negative 4y equals 8 minus 2 is not 6 in this problem because it's 8 minus 2x. So we're going to have to instead say 8 minus 2x. Well, why don't I just write that as a minus 2x and a plus 8 and not put it together? And then my next step is, okay, well, let's divide by negative 4. So I'm going to divide this by negative 4, and I'm going to divide all of this by negative 4. Which means I'm going to have y equals, these negative 4's are going to cancel, and I'm going to have negative 2x divided by a negative 4 plus an 8 divided by a negative 4. And I'm going to have some math to do here. Now, a negative 2 divided by a negative 4 becomes a positive, because two negatives always make a positive. And 2 divided by 4 is a decimal. It's 0.5. So what I'm going to do is I'm going to clean this negative 2x over 4 up. Think about it like this. Negative 2 over negative 4x. I'm going to write it on the side here. That is the same as positive 1/2 x. 2/4 and 1/2 are the same fraction. So what I'm going to do is I'm going to simplify this down to a 1/2 x. And then 8 divided by negative 4 is a negative 2. So I'm going to say I have y equals 1/2 x minus 2. And I'm going to let that be my answer. Now I'm feeling comfortable about it. Y equals 1/2 x minus 2. I know how to graph out of my head pretty quickly. So what we're going to do is we're going to set up an xy axis. So if you need to pause the video, do it so that you have time to draw your graph here. And y equals 1/2 x minus 2, we're going to go to the next page here, and we'll have this nice looking xy axis. And notice that 1/2 is going to be the m, the growth number, and negative 2 is going to be our starting number, or the b, the m and the b in this problem. So we're really good graphers. We know that if we have a graph that starts at negative 2, that we go down to the y-axis, down here, to negative 2, and we let that be the first point on our graph. So I'm going to make a little point right there, negative 2. We also know that if the growth is 1/2, then we've got what we call our rise over run. So I'm going to write it over here, rise over run equals 1/2, 1 over 2. So I'm going to be counting on the graph up 1 over 2. So I'm going to count up 1 over 2, and I'm going to have a dot right there. It's probably hard for you to see me do this on the iPad, but up 1 over 2, up 1 over 2, and I'm going to end up getting this line that's going to look something like this. It's going to be going in this direction, both directions, so I got to extend it both ways. And I'm going to add on my growth triangle here, up 1 over 2, so we're looking at a triangle that went up 1 over 2. I'll even try and shade it in if I can. Here we go. And there's my line. So it started at -2. I could circle the starting point and label it if I wanted to, and it's got a growth of 1/2. So this is kind of what we're going to practice today, and you know, some of these are easier than others. There are some really hard problems when you go to do some of this graphing stuff, so I want to get you guys really comfortable with it so you don't think it's so bad. So let's try another one here. Let's graph this new example. It's going to be x minus 3y equals 12. So again, pause the video so you can write all this down. X minus 3y equals 12. I'm going to line down the middle. I want to graph it so I know that if it was in a y equals format, everything would be easier for me. So I'm going to get it into y equals. That is my plan. So let's go through my steps for solving. First off, let's move this x to the other side. Now right now it's a positive x, so it's going to flip over to be a negative x. And we're going to move it so that this is gone and we only have a minus 3y. So we have negative 3y equals a 12 and a minus x. So I'm thinking let's just write that out as a minus x plus 12. Then all I have to do is divide by a negative 3 on this side and divide this whole side by a negative 3 and turn this into a couple of smaller fractions. So the negative 3's will cancel and I'll have y equals a negative x divided by a negative 3 plus a 12 divided by a negative 3. And so now I'm thinking, let's clean this up. A negative x divided by a negative 3. Two negatives make a positive. So really, I just have x over 3. I'm going to write that down below here. So y equals just an x over 3. Plus 12 divided by a negative 3. 12 divided by a negative 3 is a negative 4. And to make this just a tiny bit nicer so I'm ready to graph, I'm going to think of this as like a 1x. So I'll put a little 1 here, which means I have a 1/3 x plus a negative 4, so I'll just write minus 4. Make this simpler. And I'm going to get this answer of y equals 1/3 x minus 4. Now that I can graph. So y equals 1/3 x minus 4. Let's set up our xy axis. Pause the video and draw yourself an xy axis. So here's mine, y equals 1/3 x minus 4. I now can comfortably say that the 1/3 is going to be my m, and the minus 4 is my b from my y equals mx plus b. So I have a starting number at negative 4, so I'm going to do that first. I'm going to go 1, 2, 3, 4, negative 4 down here, down at the bottom of my graph. And I'm going to circle that as my starting number, get a point on the graph. I also know that my rise and my run, I'll write it over here, my rise over my run is 1/3, so it equals 1/3. So on my graph I know I'm going to be counting up 1/3. So I'm going to count up 1/3 squares, up 1/3 squares, up 1/3 squares, and I'm going to get this line going in this direction, just like that. And I'll backtrack it the other direction, like that. And to add some labels on here, maybe I'll make one of my growth triangles. So up 1/3, up 1/3, and maybe I'll circle my starting number. That was my start number. And it's a pretty decent graph at this point. I'm going to leave it just like this for now and say we're done. So it's a y equals 1/3 x minus 4 graph. So why don't you guys try one? This next example I'm going to put on the screen here. Why don't you pause the video for about 5 or 10 minutes and just give it a try. See if you can go through the whole process. Can you graph 8x plus 4y equals 20? So here's your example, 8x plus 4y equals 20. You try it, pause the video, and just go for it. Graph this line. Okay, I'm going to go through the steps. Hopefully you've done all your work. Now I'm going to show you how I would kind of tackle it. I'm going to line down the middle. And we know that this problem is going to be much easier if at the very bottom I have a y equals mx plus b. So y equals is what I want. So let's start by moving the 8x over. Hopefully that's what you guys did, made it a negative 8x. And you get 4y equals a negative 8x and a plus 20. Negative 8x plus 20. Then I think the next best step is probably to divide by 4 on both sides. So big divide by 4 on both of these sides. And we're going to get the 4's to cancel. And we're going to get y equals negative 8x divided by 4. So I'll write that down. Plus 20 divided by 4. Little fractions. And negative 8 divided by 4 is going to be a y equals negative 2x. Negative 8 divided by 4 is negative 2. Plus 20 divided by 4 is 5. This one divides out really nicely. There's no fractions left over. So you know what? That's going to be it. That's going to be my answer down here at the bottom. Y equals negative 2x plus 5. So that's the thing that goes on my final graph here. So y equals negative 2x plus 5. I'm going to go to my graph and I'm going to say that the negative 2 is the m, is the growth, and the 5 is the start. So we call that b. Y equals mx plus b. So I have to go up to 5 on the graph here. So I have my xy axis all drawn. I'm going to go 1, 2, 3, 4, 5, right about here. And that'll be my starting point. And I have a negative 2 growth, which means I'm going to be counting down 2 when I'm doing this one. I'm going to be going down 2 squares, so down 2 over 1, down 2 over 1, down 2 over 1, kind of like that. So I'm going to get a point here, and then down 2 over 1 is here, and down 2 over 1 is about here. Oops. So my line is going to go through all these points, and I'm going to try and make it look decent enough. So how about something kind of like this? Down 2 over 1. And it's going to go off in kind of both directions here. Kind of like that. And I can label all the extra stuff. You know, I might label my starting number. There's my start at 5. I might make a growth triangle that shows that it went down 2 over 1. Kind of get that drawn in. So down 2. Now if it went down 2, I should probably write like a negative 2 next to the growth triangle, because minus 2 down 2. And then that's it. There it is. There's a graph of my line. So if you felt like you did this one right on your own, you paused the video and you gave it a try, then you must be kind of getting this down. And we're going to continue to practice it in class. But anytime you want to graph a multivariable equation, change it to y equals mx plus b, and it's much easier. Okay, I hope that helps. There will be more videos on this.